Good morning, students. We are learning water resource engineering and hydrology. We are discussing on hydrological parameters, wherein in this particular lecture, we will discuss on various types of precipitation as well as the various forms of precipitation. So, we'll initiate the lecture with the first topic, that is the form of precipitations. There are various forms of precipitations. From that, some of the very common forms of precipitations are rain, snow, hail, drizzle, glass, sleet, rain, and dew. So these are the common forms of precipitation from where the water or the fluid particles that comes from the cloud on the earth's surface. Okay, so we will start with the first one, that is the rain. Well, rain is the principal form of precipitation in India. When the size of water drops of rain are larger than 0.5 millimeter. So we can say when the water drops are having the size more than 0.5 mm, that waterfall or that precipitation we can consider as the rainfall. Okay, and the maximum size of such raindrops is about 6 millimeter. Well, any drop that larger than this particular size that tends to break down into the drops of smaller sizes during its rainfall or during its fall. On the basis of the intensity of such drops, a rainfall may be classified as the light, moderate, and heavy form. So the types are light rain, moderate rain, and heavy rains. So as it varies from its intensity, we can say the light rain can be considered when the intensity of the rainfall, that is 1 to 2.5 millimeter per hour. If this intensity increased from 2.5 to 7.5, such rainfall or such rain is considered as the moderate rain, and the intensity beyond 7.5 millimeter per hour, that is considered as the heavy rain in that particular region. So in this figure you can visualize or you can observe the rainfall particles. Okay, so the next form of precipitation that we will discuss, that is snow. Okay. Now, snow is the next important form of precipitation, and it consists of ice crystals that usually combining to form the flakes. Snow forms when water vapor Snow forms when the water vapor turns directly into the ice without ever passing through a liquid state. This happens as water condenses around an ice crystal. Well, new fresh snow has an initial density that is about 0.06 to 0.15 gram per centimeter cube, and the average value of this density that is assumed to be 0.10 gram per centimeter cube. Well, snowfall in India is usually confined only to the Himalayas region, but we all know that in countries like Canada, US, that is America, Russia, China, where such snowfall occurs. Hence, this snowfall is the major part of their precipitation. That is in Canada, US, Russia, China, etc., where there is a cold region. Okay, so at cold regions, snowfall are the major part of the precipitation. We'll discuss about the hail. Hail is created when moisture and wind both are together. So inside the clouds, ice crystals form and begin to fall towards the surface of the earth. So when this falling down starts to happen, wind gusts start to pick up the ice crystal that pushing them up high into the clouds. As they start to fall down again, they continue to grow in the size that is more than 8 millimeter. A wind gust might catch the hailstone again, which will push it back up into the clouds. And this whole process gets repeated several times before the hailstone becomes so big that it is too heavy for the wind to carry this particle, so it must fall down towards the earth. Okay, this is the hail particles. Sometimes we have observed such particles even in India sometime before. Okay, now let's talk about the drizzles. Fine sprinkle of numerous water droplets of size less than 0.5 millimeter and the intensity less than 1 millimeter per hour, that known as the drizzle. Well, it is a bunch of small droplets of water which are in the air. This occurs with the cold air when it is above a warm surface. Let's, for an example, we can say the water. Fog and drizzles are very similar. The only difference between fog and drizzle, that is its visibility. If you cannot see 1 kilometer or less, you know you are dealing with the fog. And you can see the visuals through the drizzle. So that is the major difference between fog and drizzle. It is more haze looking than a thicker substance. Well, drizzle is more haze looking than a thicker substance. You can see here the drizzle looks like a kind of bunch of water particles that is spilling on the surface that we generally observe on the glass. The next form of precipitation, that is glass. Well, when the rain or the drizzle comes in contact with cold around like point or like around 0 degrees Celsius, the water drop freezed to form an ice coating that is called as a glaze, or we can say the freezing rain. Here you can see an image of a glaze situation. So when a precipitation like glaze occurs, it looks like this image, where you can see surrounding areas are completely frozen. Okay, and it make a kind of coating of ice on surrounding things. So that will be the glaze. Next form of precipitation, that is the sleet. Now, sleet consists of transparent, globular, solid grains of ice formed by the freezing of raindrops, or we can say freezing of largely melted ice crystals that falling through a layer of sub-freezing air near the Earth's surface. This is how we can say a sleet looks like. Okay, the next form of precipitation, that is rain. Well, rain is the white epic deposit of ice granules more or less separated by trapped air and formed by a rapid freezing of supercooled water drops that impinging on exposed objects. Well, the specific gravity of Rhine may be as low as 0.2 to 0.3, and Rime looks like are these particles, or we can say the ice granules. Okay, the next form, that is the dew, that we all have observed. Now, dew forms directly by condensation on the ground, mainly during night when the surface has been cooled by outgoing radiations. Also, dew is the small drop of water which can be found on cool surface like grass in the morning. Okay, so these all are the various forms of precipitation. So as recalling that forms, first we have learned about rain, snow, hail, drizzle, glass, sleet, rime, and at last we have discussed about dew. Okay, now the next topic, that is the types of precipitation. So precipitation is often classified according to the factors those are responsible for lifting. So the specific four types of precipitations are cyclonic precipitation, convective precipitation, organic precipitation, and the last one, that is precipitation due to turbulent. While talking about the first one, that is the cyclonic precipitation. Cyclonic precipitation is caused by lifting of an air mass because of the pressure difference. Well, if low pressure occurs at a particular area, the air will flow horizontally from the surrounding area, and that causing the air at the low pressure area to lift. Well, the cyclonic precipitation may be divided into two parts. The first, that is the frontal precipitation and non-frontal precipitation. Talking about the first one, that is the frontal precipitation. So when two air masses, because of the contrasting densities and temperatures, when clashes with each other, the precipitation and condensation occurs in the surface of the contact, where you can observe that in here. So here they get contacted with each other, okay, and at such places precipitation and condensation both occurs. Well, the surface of contact is generally called as the front or the frontal surface, and the precipitation occurs in such cases is known as the frontal precipitation. So when a cold air mass that drives out a warm air mass, that is known as the cold front. Okay, but if a warm air mass replaces the retreating cold air mass, that is known as the warm front. And on the other hand, if both air masses, okay, when both the air masses, that is cold and warm, are drawn simultaneously towards the low pressure area, the front developed is stationary, and such kind of precipitation, such kind of contact generated, and at such moment the particular frontal side, that is known as the stationary front. So the cold front that causes intense precipitation in comparatively the small areas, while the precipitation due to the warm front is less intense, but that spread over a comparatively large area. Cold fronts move faster than the warm fronts. Okay, so this was about the cyclonic precipitation, wherein we have divided this cyclonic precipitation into two parts. The first one frontal and second one non-frontal. Till time we have discussed about the frontal precipitation. Now if we discuss on the non-frontal precipitation, in case of non-frontal precipitation, the moist warm air is stationary and the moving cold mass meets the stationary air, the stationary front we can say, and the cold air mass and the moving cold air mass meets the warm air mass, wherein the warm air mass is stationary, means it's steady, and the cold air mass meets that warm air mass. Now thus, due to the lightness of the warm air mass, there is a passive ascent of warm air over the cold air, that is owing to this particular active undercutting. So when this lifted warm air cools down at a higher altitude, precipitation occurs. Okay, so this is how the cyclonic precipitation occurs in two forms, frontal and non-frontal. Next is the convective precipitation. Well, convective precipitation is caused by the natural rising of warmer, lighter air at the colder, dense surrounding. Convective precipitation is caused by the natural rising of warmer, lighter air at the colder, dense surrounding. Difference in temperature can result from unequal heating in the surface, unequal cooling in the top of the air layer. Generally, a kind of precipitation occurs in tropics, where on a hot day the ground surface gets heated unequally, causing this warmer air to lift up as the colder air mass comes to take its place. The vertical air currents develop tremendous velocities and are hazardous to the aircraft. Convective precipitation is spotty and its intensity varies from light showers to the cloud burst. The third one, that is the orographic precipitation. Orographic precipitation is caused by moist air masses, which strikes some natural topographic barriers like mountains that causing rise up, condensation and precipitation. The greatest amount of precipitation falls on the windward side, and the leeward side often has a very little precipitation. Here you can see the upward side and the lower side. Here you can see this is the windward side and this is the leeward side. So the rainfall is composed of showers and steady rainfall. The last type of precipitation is the precipitation due to the turbulent ascent. While the air mass is forced to rise up due to the greater friction of the Earth's surface after its travel over the ocean, then the air mass rises up because of increased turbulence and friction, when it ultimately condenses and precipitation occurs. While the winter rainfall in Madras is mainly due to this turbulent ascent process. Okay, so this was all about the types of precipitation. We have four different types of precipitation: cyclonic, convective, orographic, and the precipitation due to the turbulent ascent. Wherein in the cyclonic precipitation we have discussed about frontal precipitation and non-frontal precipitation. Okay students, I hope you understand the topic thoroughly. Thank you so much for your kind attention. We'll see you in the next lecture.